This is a project with Charya Koyan is now at DoorDash. I guess I should clarify, not as a driver, as a machine learning specialist. Also joined with Raj Vasu at University of Wisconsin. And for those of you I don't know or don't know yet, I'm Mike Andrews at University of Maryland, Baltimore County. Um, okay, the question in this paper is basically what do we know about how valuable firms' intangible assets are? So if we look at something like a 10K, this is basically all we see. Maybe I'll start with a short confession. This is Apple's 10K from 2017. This is one of these very old projects, but very new paper. When we started this project, I guess Apple was the biggest company in the world, and 2017 was their most recent 10K. So times have changed, but the idea of what's currently disclosed about intangible assets, at least under GAAP, is I think still fairly similar to a few years ago. Basically, under GAAP, firms only report aggregated values for their acquired intangible assets. So what this means is we don't see anything about how valuable are intangibles that are generated internally, right? So if I create a patent in-house, even if that patent is going to generate a huge amount of future cash flow for the firm, we just don't see how valuable that is on financial statements. And we only see aggregated values. That means we don't see like individual values for individual intangible assets. The reason for this, I think, at least for those of you familiar with the accounting principles, is really fundamental, really a bedrock idea of modern accounting called the reliability principle. Basically, we only want to report information that we can verify with objective evidence, right? And intangibles, just by their very nature, if they're not bought and sold, uh, it's very hard or impossible to sort of validate how much is that thing actually worth. So we just don't typically report those. Uh, the thought experiment in this paper is, well, if we did actually require firms to report values for all their intangibles, not just acquired stuff, but also intangibles that are generated internally, would that information be reliable? So how we go about this is we're going to introduce data from a novel historical setting in which firms operated under alternative rules for intangible asset disclosures. In particular, these rules are going to make no distinction between whether intangibles are acquired or generated internally. And these rules are going to require that firms provide an itemized list of intangibles and their values. So what this means is we're going to see both internally generated and acquired, and we're going to solve this sort of aggregation issue as well. And then once we have this historical data, we're going to use tools from forensic accounting to try and test and see if these reports are valuable. Just a quick preview of what we find. We're not going to see any evidence that firms are reporting in bad faith. So it doesn't look to us like firms are strategically manipulating the numbers that we report. We do find substantial evidence that firms themselves just don't know how valuable their own intangible assets are. And maybe I'll get into why we think that as we move through. Let me just talk a little bit about this historical setting. So we're going to look at the 1919 Illinois Blue Sky Law. So blue sky laws were essentially early investor protection laws, so the period, of course, before the Security Exchange Acts. The idea was if you, and these were passed, almost every state in the US passed these from the early 20th century up through the early 1930s. For basically all of these acts, they varied quite a bit by state, but the basic idea was if you wanted to issue securities in that state, you had to provide some sort of information, some sort of public disclosure that you'd submit to a state regulator. Okay, so basically, with the Illinois law, this was recognized as one of the most stringent in the entire country, both stringent in terms of how much information did you have to provide, and also how strongly it was enforced. So with this Illinois law, if I wanted to issue securities in the state, I would have to submit to the regulator a detailed report, which included things like when and where was my company founded, description of what kind of business I'm in, company history, names and addresses of all firm officers and all firm directors, what kinds of securities I'm trying to issue, what I'd like to do with those funds, and then, of course, financial statements, so things like balance sheets, income statements, other statements, and other schedules. What's most exciting to us is down here, firms also had to submit an itemized description, including values for their intangible assets. And as I said, this law is going to make no distinction between acquired and internally generated intangibles. Let me just also mention one more quick thing about the sample here. Um, the law is going to exempt any firm that's traded on a large national exchange, so New York or Chicago. We think this is sort of independently interesting. This gives us insight into a set of firms that are not traded on public exchanges. Kind of a sample of firms we don't typically know a lot about. So just sort of as a business and economic and accounting history, we think that's interesting as well. Okay. Uh, this is the specific section of the Blue Sky Law that talks about intangible disclosures. So patents, copyrights, trademarks, processes, goodwill, or other intangibles should be itemized and should not be carried as an asset in amounts exceeding the actual value of said several items. The cost and present value of such items should be separately set forth in this Schedule 7. Some years it's Schedule 6, some years it's Schedule 8. We'll just refer to these as Schedule 7 of the firm reports. So we're going to actually get to see these valuations that typically appear in aggregate on a balance sheet as well. Okay. What do these data look like? We spent a lot of time in scenic Springfield, Illinois, at the state archives collecting these reports so that they are come out of the archives looking like this. In almost every case, we're the first people to look at these in 100 years since they were filed in the 1920s. Uh, let's look at an individual report. So this is Moline Heat, a company that makes heaters, filed in March 1920. You can see these reports tell us a little bit about the history of the company. Originally, this company was named something else. Actually, I think made vacuum cleaners. Transitioned into the heating business, changed names. Let's see. We know something about the name, incorporation, where were they incorporated, much more information. We get balance sheets, which uh, I'll just highlight down here. We see something about the intangibles that they hold on the balance sheet. So $25,000 worth of patents. They also have an additional intangible, a promotional expense that they carry as an asset here. And then what's most interesting to us is the schedule, in this case, Schedule 6, we'll refer to in most years as Schedule 7, detailed explanation of what these patent and other intangible assets are, how much they're valued, and why they're valued this way. So there's two sets of patents actually that Moline Heat is including. One they value at $15,000, another at $10,000, and they explain exactly what those patents are and how they arrived at that valuation. So again, to us, very exciting to have this kind of disaggregated and also rich and detailed data on how those values were arrived at. Again, both for internally generated and acquired patents. Just to give you another example, this is from a different company. So this is the CF Peace Corporation, which produces washers and dryers. And here they actually list, an individual valuation for each individual patent that they own. So different firms sort of handle this within their Schedule 7's aggregation issue in different ways. In all cases, it's really rich relative to what we see in financial reporting today. Okay. I should say transcription is moving along. Anticipate being finished soon. It is still in progress. At the moment, we've transcribed reports from 1,158 firms. 1,158 firm reports. These are coming from 458 distinct firms covering the years 1919 to 1948. Most of these in the earlier years at this point. These reports are going to contain 509 distinct valuations of intangible assets. So as we saw from the previous pictures, each firm report, if they own intangibles, can include multiple valuations that they report. And as we saw from Moline Heat, each of those valuations of intangible assets may include several different identifiable intangible assets, or even not identifiable, but different line items for intangible assets. So we have 509 distinct valuations covering 3,875 intangible assets. If we wanted to focus on a specific type of intangibles, if we wanted to focus in this case on patents, 145 reports coming from firms that have a patent, and these come from 96 distinct firms. Okay, so just a couple things to highlight here. When data collection is finished, this will be about 1 out of every 6 firm reports filed with the Illinois Secretary of State. And I just want to note, to the best of our knowledge, and those of you in the audience doing some accounting and business history, please correct me if we're wrong. I think this is the largest collection of financial information for firms that are not traded on public exchanges that we have for this historical period currently uh, put together in a format that researchers can use. In the baseline results I'm going to show you, we're going to be using the first report filed by each firm. The reason for that basically follow-up reports tended to be supplementals. They were less rich in terms of providing itemized information on intangibles. There's also some issues about how much firms are amortizing or depreciating their intangibles over time, or in many cases they're not. They're reporting identical values in each successive report. So we just think it's safer to focus on these first reports, but results are very similar if we used all reports instead. Okay, so we have all these valuations of patents that we've collected from these firm reports. What do we want to do with them? And the first question we want to ask is, well, are these valuations actually made in good faith? To do this, we're going to rely on the tools of digit testing, which are commonly used in the forensic accounting literature. In particular, the idea here is that if data are not manipulated, if they're actually real data, not strategically manipulated by the firm, they should follow a well-known distribution known as Benford's law. Okay, this we're not the first people to recognize this idea that we can look at first digits of distributions to think about whether these data are manipulated or not. This has been recognized quite a bit. It's been used in the accounting literature to identify earnings manipulation, tax evasion. It's been used to identify academic fraud, election fraud. This kind of distribution actually occurs a lot in nature. So we see these distribution of first digits in the lengths of rivers, stars, and galaxies. And so the idea here is that if these digits are manipulated by firms, uh, our data should deviate from Benford's law. I think I have time. Let me take a couple minutes. If anyone here is not familiar with sort of this digit testing approach in forensic accounting, kind of the question is, we've got all these reported valuations. Let's look at the first digit of each of those valuations. What fraction of those digits do we think are going to be a one, right? And I think naively, we would think probably about 1/9 would be one, right? We think the distribution of digits should be approximately uniform. It turns out that's not the case. So this is how I like to think about the intuition for Benford's law and this Benford distribution. Let's suppose we have a lottery. So we have balls in an urn. These balls are labeled sequentially, right? We're going to draw a ball from the urn, and we want to say what's the probability that ball is the number on that ball begins with a one. Okay, if we have two balls in that urn, the probability is just going to be 50%, right? Either we draw the one or the two. Now on the x-axis here, I'm just going to plot how many balls are there in the urn. If we had three balls in the urn, the probability that first digit is a one would be 1/3, right? If we had four balls, that would be 25%. Five balls, 20%. And this just continues to decline until we have nine balls, where 1/9 of the balls should begin with a one, right? Now, when we add that 10th ball, stuff starts to change, right? All of a sudden, the probability is 2 out of 10, 20%. And it goes up with the 11th ball, the 12th ball, all the way up to the 19th ball, right? We're now, what is this? 11 out of 19 of our balls begin with a one. And then, of course, with 20, this begins to fall again. It's going to fall all the way up to 100. So we get kind of this sawtooth pattern as we add more balls. We can plot this out to 1,000. Again, increases after 100 and then falls after 200. We could go all the way out. We get this sort of serration show up again and again. Uh, if we take the limit as this goes out to infinity and take the expectation, we find that about 30.1% of the time, that first digit should be a one. So the way to think about this Benford's law, I think really the way to think about it is as a lottery over lotteries. So let's first draw how many balls are in our urn, and then from that number of balls, draw a ball. Okay. We can calculate this for other digits as well, and we get a distribution of first digits that looks something like this. So it's not the case that the distribution is uniform and every digit appears with equal probability. One should appear almost a third of the time. Two should appear almost 18% of the time. 3, 12%, etc. And until we get to these higher digits, 7, 8, 9, they should appear less than 6% of the time. We can derive an expression for this as well. So this is the distribution we're looking for. Unmanipulated data, first digit should basically follow a distribution that looks like this. And again, this has been recognized empirically in a lot of contexts and actually used to detect fraud. To the best of our knowledge, we're the first people to apply this to patent data or historical patents, but it's a well recognized technique in the literature. So, do the first digits of our reported patents and other intangible assets follow Benford's law? This is all intangible assets that show up on firm Schedule 7s. And this fit is pretty good. It's not perfect. Yeah, often statistical tests will reject that this is identical, but we actually think this is pretty good. So this is all intangibles. We look just at patents. Actually, it's even closer to Benford's law. Um, One point I want to make, a lot of the concerns with our reliability principle is that acquired and internally generated intangibles might look quite different, right? In particular, if stuff is internally generated, that's exactly where we should expect to see more strategic manipulation of these reported values. That doesn't appear to be the case here. These distributions are both quite similar to Benford's law, and in fact, quite similar to one another. So statistical tests reject that these distributions are actually different from one another. Um, if we look just at reported valuations on balance sheets rather than the Schedule 7s, we find even closer matches to Benford's law. So these are patents here on the left, all intangibles on the right. All intangibles, we have a lot of goodwill that's valued nominally at $1. So we have a few more one digits than even we would expect under Benford's law. Patents, again, follow quite closely. And we can kind of benchmark this to other financial variables that get reported. I'll just show you some from the balance sheet here that we have no problem disclosing today, and we can see whether the patents and other intangibles follow more closely or not, right? So if we looked at, say, real estate, I think this is a useful comparison because similar to intangibles, real estate is an asset that is pretty illiquid. Every asset is unique, right? It can be hard to find a comp for a particular property, similar to intangibles. And in this case, we actually see that intangibles follow Benford's law closer than real estate, right? So to the extent that these forensic accounting tools are identifying potential manipulation, it's actually less likely in intangibles than it is in real estate. It's also a little bit less likely to occur in patents than it is in machinery and equipment, and even if we looked at total asset values from the balance sheets, although these are quite similar. Um, I won't talk about robustness and all of this in the interest of time. I'll just mention what I've been showing you is just looking at pictures and kind of eyeballing it. We can test these things with chi-square tests and things like that to see how similar distributions are to the predicted Benford distribution. And again, in most cases, they're quite close. And our distributions of patents and intangibles tend to be closer than the distributions first digits for other variables. And I won't mention these other things in the interest of time. I'm happy to talk more during the Q&A. Okay, so our takeaway from all of this is there's just not strong evidence that firms are reporting intangibles in bad faith. And what I mean by that is no strong evidence that firms are strategically manipulating these values in this context where they're required to disclose them, even if patents are internally generated. Okay, so if they're not reporting in bad faith, if they're not strategically manipulating these values, that must mean that these reports are reliable, right? And I think the answer to that really depends what we mean by a reliable reporting of a value. So what our conclusion here is that they're not reporting in bad faith. We don't think there's strong evidence that firms are strategically manipulating the values that they report. But we do think firms themselves are just not certain of the value of their own intangible assets. Why do we think this? I'm going to show you two pieces of evidence here. The first, we can look at the precision of the valuations that firms provide. Okay, and it turns out firms are less able to value intangibles precisely than other kinds of assets. You can sort of think of this as like a cross-sectional way to think about, am I able to assign a specific, exact, precise value for this class of assets? If I'm not, if we see a lot of evidence of rounding and things like that, it's probably evidence that I'm not exactly sure what these things are worth. We can also think of sort of an over time measure of uncertainty, a sort of a panel type measure, where we can look at values of intangible assets that are reported in firm reports today and see if these are correlated with other measures of the quality of these intangibles from later in their life. And again, if firms are highly uncertain, this correlation should be quite low. So we'll see some evidence of that as well. Okay, first of all, let's think about how we would think about measuring imprecision in reported values. So we want to continue to stick with these digit tests. The idea here is that different kinds of digit tests are telling us different things about the reported valuation. So we just saw on previous slides, if we think valuations are not manipulated, they should follow this Benford's law. So that's sort of a test for manipulation. Now, if we want to think about uncertainty or imprecision, instead of looking at the first digit, we should look at the last digit. Okay, and the last digit of a reported valuation, if we know these values exactly, should actually follow a uniform distribution, right? So 0 through 9, those digits should all appear with roughly equal probability. Okay. If we see things like zeros or fives appear much more often, this is evidence of substantial rounding, which we interpret at least as evidence that these firms are not certain about the quality of their assets. I think that the analogy we like to make is in the demography or economic history literature, we'll also see people measure age heaping to measure numeracy, right? So if people are much more likely to report that their age is, 30 rather than 29 or 31, it's probably a good indication that they're just not very sure of their exact age. It's the same idea here. If we see a lot more patents valued at, $200,000 rather than 200,105, right? Like that's evidence of some sort of rounding or uncertainty about the exact value. And we see a lot of heaping on zero when we look at intangibles, right? So this is, excuse me, this is all intangibles. Sorry, I think this is all patents. My title slides are blocked by illusion. Yeah, all patents. If we look now at the balance sheet, even more actually clustered on zero. And what we can see is that these distributions for patents are much more clustered on zero than the last digits of other financial variables. So this is real estate, where we also see some rounding here, but nowhere near to the extent that we see with patents. Machinery and equipment, pretty flat. Total assets, pretty flat. Some other ways to think about this, you can think like, do we report the valuation down to the penny, or do we report large round focal values? By focal value, we just mean every single digit except the first one is a zero, right? So 200,000 is a focal value, but 250,000 is not. About a third of the patents report the valuation down to the penny on Schedule 7. Actually, more report a big round number than report values down to the penny. If we look just at the balance sheet, many more actually use cents. I'm actually not sure why that's the case. When you aggregate more, we actually see a little bit more precision and fewer are focal values. But if we put this in context by looking at things like machinery and equipment, real estate, or total assets, here almost everybody is reporting down to the penny. Almost nobody is reporting big round numbers, where we still see substantial numbers of this when we look at intangibles. So again, we just interpret this as evidence that these firms are really unsure about exactly how much their patents are worth. This is also not just a case of rounding because the value is very big, right? If we split patents on high valued and low valued, we see a lot of rounding for both. Okay, the last thing we do, I'll just mention this very quickly, is try and take measures of the lifetime quality or importance of a patent from the literature. Here we're going to use this measure of patent importance from Kelly et al. Basically, we look at the text of a patent, look at how similar it is to everything that's come before. If a patent's very different from everything that's come before, it's very novel. And if it's very similar to everything that's come after, it's impactful. And an important patent is one that's both novel and impactful. So we basically take the ratio of those things. So we're going to take this measure of patent importance from Kelly et al. And just regress it on these reported valuations. And the idea is if firms were sure of the quality of their patents, this correlation should be strong, positive, and significant. That's certainly not what we find. We find effectively a zero here. I should mention this is not just driven by acquired versus internally generated patents. We actually see fairly similar results for both, right? So if you had sort of an Akerlof story in mind where if I have private value of something, maybe it's less likely to get transacted. That's not what's driving the results here. We can also split this up by how the patent is valued. And here, I think we see some interesting results that I'll probably have to skim through very quickly. But if the patent is acquired and the value is reported at the purchase price, the correlation is fairly weak, but we actually do see that this reported value correlates with future measures of patent quality. So that's kind of interesting. I think that's sort of consistent with current GAAP rules where we only report values of acquired intangibles. But sort of contrary to the reliability principle, what's special about purchase patents is not that like there's a paper trail, because we can look at cases where firms report patent values at the cost to develop it, right? So R&D costs plus attorney fees. There's a paper trail for that as well, and we find effectively zero correlation. And I think that's kind of an interesting null finding in light of IFRS rules that we can capitalize patents at the development cost, things like that. The one case where we maybe see some evidence of strategic manipulation is actually if a professional accounting firm is involved to actually appraise these things, where we actually see a negative correlation. Kind of interesting to us. Let me wrap up. So, are reported intangible valuations reliable, at least in this context? I think the answer is sort of, right? We see no evidence that firms report intangible values in bad faith. And I think interesting in light of GAAP rules, there's no difference in reported values between acquired and internally generated intangibles. That being said, firms do appear to be really uncertain about the value of their intangible assets, right? They're unable to value these things precisely, and the reported values are only weakly predictive of future measures of quality. The last point I'll make is just a data point on the data contribution. We introduced a new data set on historical firms not traded on public exchanges. We think that's pretty cool, and I think we're just scratching the surface for the kinds of things we can do with these data. So, we have some ideas, but hopefully those of you who study business and accounting history in the room may have some ideas as well. We'd love to hear them. So let me stop here. Thanks a lot.